Hello everyone. Today we will be continuing our discussion of apportionment with what is known as the Huntington-Hill method. Now, I will present a brief overview of this method in this video. However, I would like to refer you to the last video over Adams's method and Webster's method for a more elaborate example. Why? Because the Huntington-Hill method is almost identical to Webster's method. The only difference is the cutoffs that are used for rounding of quotas. So, very similar to Webster's method, with the Huntington-Hill method, we are using a modified divisor, which in this case may or may not be equal to the standard divisor. And then we are using modified quotas to assign seats. However, unlike Webster's method, rather than using conventional rounding of the modified quotas to figure out how many seats are going to go to each state, we round based on what's known as a geometric mean. And what a geometric mean is, basically, we multiply the upper quota or the lower quota and upper quota together, and then take the square root of that. So I have a table right here on the board of what the rounding cutoffs are for different, basically different pairs of upper and lower quotas. So for an example, if the lower quota is 1 and the upper quota is 2, we multiply those together. That gives us 2. Square root of 2, that's 1.414, and so forth and so on. Lower quota 2, upper quota 3, we multiply those together. Square root of 6 is 2.449, and so on. And we just keep doing that basically all the way down this table. So one thing you'll notice is that the higher the lower and upper quotas get, the closer this decimal part gets to 0.5, which means the closer the Huntington-Hill method is to, effectively, to Webster's method, which employs conventional rounding. Now, the Huntington-Hill method is actually the method that is currently used by the U.S. House of Representatives. That's probably the most notable application of the Huntington-Hill method. Thank you for watching, and as always, I'm happy to help with any questions you may have.